Okay, so hi and welcome to Geeks for Geeks. Today we would be discussing the GFG Weekly Coding Contest 104, which took place at 7 p.m. and ended at 8:30 p.m. So now before we move forward, let's talk about what I thought about this problem. So let me just remove it to the Mm, yeah. So let's talk about how I think that this was the problem. So I think that for like, yeah. So for me, the problem was an easy problem if you are able to think a little bit. Okay, why think a little bit? If you are acquainted with the properties of trees, if you know DFS, then you are able to take down two problems. Okay, and the second problem was a tricky approach, like not a tricky, a pen and paper approach of greedy itself. Now, if you are in this editorial video or so-called post-contest video, then I would suggest you that you shouldn't see the solution of the internal. Why? Because the internal solutions are a little bit complex, I think so, and I have a simpler solution to everyone. Okay, so first question was hard. Mm, if I see the trends of the previous contest, yes, the first question was a little bit hard. Why submission is taking a lot of time? It might be a scenario with the server or something. So we'll forward it to the team. Okay, fair enough. Now let's move forward with the very first problem. The very first problem was density of the tree. So now let me just share the screen itself. Where can I find it? So the window. Yep. Mhm. Yep. Okay, fair enough. So now let's start. Just let me see. Yep, it is getting drawn down. Okay, so now let's see this problem. Okay, so in this problem, we are given that there is a tree of n nodes. Okay, what we are given? We are given a tree. Okay, of n nodes and n minus 1 edge. This is given, and it is told that 0 is what? 0 is the root of the tree. So we are given a rooted tree at 0, and then we are given this. Now we are given that we need to, like, let's first draw the tree. So suppose we have a tree like this. Okay, let's say 1 and 2. Now we are told to find the density. Okay, now for finding out the density, we require the size of the tree and we require the height of the tree. Fair enough. Now let us first talk about what is size of a tree. Size of a tree is nothing but total number of nodes. Total number of nodes. Okay. So first we need to find the total number of nodes in a tree. Okay. So you can simply do a DFS, count the number of nodes you are visiting. At the end, you can say this is the total number of nodes. But there is a simpler solution. The simpler solution is that in the question itself, they mentioned that there are n nodes. Okay, if you see closely the question, given a tree of n nodes. So now you don't really need to find the total number of nodes. You can directly say that yes, n is my answer. If n was not given, if let's say a graph was given, then you can simply count the number of nodes by using a DFS. First thing is done. Then we are told that find the height of a tree. Okay, so now let's go a little bit up so that we can just discuss. height of a tree. Okay. Mhm. Okay. We are to find out the height of a tree. Finding out the height of a tree can be done by BFS, can be done by DFS. Anything you say. How do we find the height of the tree? First, I would give you the idea. The idea is that we start from the root. Okay. Then we go down, we say 1. Okay. First, let us see what do you mean by height of the tree. The height of the tree means that longest longest path from root to any leaf. What do I mean by this? Let's first understand. Where yes, by using level order traversal we can do. I'm just trying to make it as generic and possible. Okay. और सर मत बुलाओ भाई, इतना भी नहीं, भैया बुलाओ. ओके है. ओके, भैया बुलाओ, सेठ बुलाओ, यही बुलाओ, ठीक है. ओके, इतना भी बूढ़ा नहीं हुआ मैं. Okay, fair enough. Let's start with this thing. Say we start, let's say we are given a tree. Okay, like this. We are given a tree like this. Okay, so the height of the tree would be what? The height of the tree would be, see here, the height is 1 2 3. So we found out 3. Now we can say that here the height is again 3. Okay, the height is again 3. So we can say this is that. Now we can again travel from this, height is again 3. Okay, now we are again travel from 1 2 3 4, and we can say the height is 4. So the longest was how much? 4. So the height of this tree is nothing but height is 4. Okay, fair enough. Now how can we count the number of height? This is very important. Okay, to count the height, what we can do is we can first say that the height of the root is 1. Okay, we start from the root. See how we are counting. Then we would go to the neighbors of root and we would say the height of the parent plus 1. That is 1 plus 1 is equals to 2. And here also we would do the same thing. 1 plus 1, that is 2. 2 plus 1, that is 3. 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 And 3 plus 1, that is 4. Okay, we can do this thing. The idea is, if I conclude it with an example, it would be something like this. Suppose my father in his lifetime earned 1 crore, 1 CR. Okay. And then I earned, let's say, 1 CR also. So the earning of my father plus my earning, it would be the hereditary earning, or just so-called pustaini paisa. Okay. So now I would have 2 crore. So in the same manner, if this parent, let's say, let's take the example, if this parent has the height of 2, then if we go down, it would be the height brought by my parent plus 1, that is 3. Okay. So what we can do is we can simply do a DFS. Okay. And there are 2 ways you can do a DFS. So I would just, because I would suppose that the that person who is seeing the editorial of the first problem is a newbie in programming. So what I did was I just kept a height variable as 0. Okay, and then I started with the root as 1. Okay, and then I just made a root. First I would build out the graph itself. Now let us build out the graph and let's understand this. So now it is very easy. By doing this method we can find the height of the tree. We already have the size also. So if we have size and height, then we can just divide and return as the density itself. Okay, so now I would stop the sharing of this. I would share the Chrome tab itself, density of a tree. First tell me if this thing is clear or not. Okay, where can I find my score? वो देख लेना थोड़ा सा. Okay, yeah, level order is fine, but it would have taken relatively longer time to code. Yup, DFS is a small bit of program and it would take less time, so I found it that it would be a little bit easy. Okay, fair enough. Let's move and let's keep it here. Let me just remove it. Okay, first tell me, others, can I have a quick yes or no? If this thing is clear, give me a quick 1. If this thing is not clear, give me a 0. I would again explain with an example. But this is the first problem. I don't think it would require more time. Okay. So let's just present the screen. Density of a tree and let's start. Okay. So now I would say that we can do it using global space also. We can do it by anything. Okay. So now I would say I would first code the DFS part. Okay. So what is DFS? DFS is we take a source. Okay. And then we just visit its neighbors. Okay. Auto E G of S. What is G? G is a graph. And then we would just pass on to this S. Now let's first build out the graph itself. I'm a very lazy person, so instead of uppercase N, I would be writing lowercase n. Instead of tar, I would be just writing P. Okay, fair enough. Now we would declare a vector int g of size n. Then we would build out the graph itself. Okay, now we would say that for int I is equals to 1. Why? Because we already know that there is no parent of the root. Okay, it is true. Parent of the root is -1. So there is no need of processing it. So now I is less than n and I plus plus at this point. Now what we would do, g of p of I dot push back I. Basically, we would just process the graph in the form of directed graph. Okay, you can just form it in the form of indirected graph, but you would also require the usage of visited array. So it's better that you build out a directed graph. Okay, now let's move forward. Now we would initialize something known as height. Height is equals to 0. Okay, and then we would run the DFS function. We would call the DFS function. But how would we call it? So we have the source. So here we also need the distance, because the source would be passed with distance 1, depth 1, then depth 1 plus 1. So depth plus 1. So we need the depth also. Okay. Then we would also require the graph itself. Okay, like the tree itself. Vector int and G. Okay, G. And then we would also require pass by reference, because we would update it. Okay, so HEIGHT. Okay, so now what we would do is at this point we would say HEIGHT height is equals to max of height comma D. Okay, now at this point it would be DFS of E. This time if we go down, it would be +1. Whatever the distance was upside there, then +1. That is D plus 1. Okay. Then we have the graph forwarded and height forwarded. Okay, and this is done. Now we would call the DFS with the source as 0. We would start from the very root itself. Then we would start with the distance as 1, because the root is at 1. Okay, then we have the graph and the height itself. At the end we would return the density. What is density? Formula of density, it is given as size of the tree. Size is n divided by the height of the tree. Height of the tree is what? Given in the HEIGHT. Okay, but if you see both are integers, an integer divided by integer would result in integer, but it requires long double. So what we would do is we would typecast it to long double before dividing. And if we divide long double by long double, it would result in long double. I hope I'm not making any errors. I'm making some errors. hmm Okay, 0, 1, H, okay, EDG, declaration of the. Okay, array don't need to be passed by reference. Array is passed by reference by default. Hmm. Done. So now see the solution and then let me know. So to be honest, if you just see the solution itself, like I first coded out the DFS, like the BFS approach, then I saw that even DFS can work. Then I initialized that even without the visited array, I can do it. That is why I tried to make it as optimized as possible. Okay, so now I would submit it. Here is a better approach. Unordered map. The no, this is not a better approach because the worst time complexity of unordered map is big of n. So try to avoid it as much as possible. Okay. भैया आप ये loop density I did not understand. To be honest, I'm happy to because of this. Many people are making sacrifices, not just me as a mentor. Okay, will the contest be public? Yes, it is public. भैया ये for loop inside density. Okay, for loop inside density. So density requires size and height. So I found it. Now you tell me which line are you talking about? Just mention the line number. This is not a better approach. Can I iterate array and count level? Yep, absolutely. You can iterate it and count the level. But DFS is a very small thing and everyone can do it. So I thought DFS would be more generic. So if you're done with this problem, give me a quick one and then I can move forward. 22, line number 22. Okay, so basically here we are given that we are not given the tree, but we are given the parent array. So we need to build out the tree on by ourselves. So see, the parent of 0 is -1. That means 0 has no parent. See, 0 has no parent here. Then the parent of 1 is 0. So the parent of 1 is 0. The parent of 2 is 0. So see, the parent of 2 is 0. Okay. I mean, I can see the contest put on the page, which also has the forum. Okay. Code with Akash. Am I clear to you? Kindly just confirm. Second wala DP का problem है. No. Second is not a DP problem. Like it can be solved using a greedy method too. I would show you. Okay. So I think we are pretty good to move forward to the next problem. By the way, if you just see the solution, then it is a very long solution. And I would suggest that don't go in this fashion. Like this is a very like the it seems very big. We don't need to calculate the size basically. Size is already given that there are n nodes. Total number of nodes is the size, so we don't need to calculate the size. We can just surpass it. That would be a better cunning approach. Mhm. Thank you, Code with Akash. Fair enough. Let's move forward. Mhm. 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 Yep. So now this problem is like this problem. I when I solved it without using DP, I was happy to. Okay, fair enough. Like, can I show you my summation? Yep. So actually, what happened was initially I found out the greedy approach, but then I found out that the same solution is giving TLE. So first I debugged the solution, then I found out that still my solution, like this was some, like I was testing it before the contest, and if you see the same solution earlier it was giving TLE, then I talked with the team, then I made it, and just before the contest I had a submit and I got the AC for the same solution. So actually the internal test case was wrong for this. You should thank me. चॉकलेट मिलना चाहिए सबके सबके लिए सबके तरफ से. Okay, fair enough. Now let's see. We are here in this problem. We are given an array. Okay, we are given an array. We are given the size of the array, and then we are given an integer k. We would talk about it. These are the things that are given. Okay. Now you can perform operation on each of the element. Okay, so you can perform operation on each element. Okay, but the constraint is that only once. Okay, you can perform this operation only once. Okay, now what kind of operation? There are three kind of operation. Okay, and you can perform either of them, but on each you can perform either of the operation in each element but only once. इन तीनों में तीन ऑपरेशन दिए गए हैं, तीनों में से कोई एक भी ऑपरेशन उठा के एक एलिमेंट पे आप कर सकते हो, बट हर एलिमेंट पे एक ही बार करना. व्हाट काइंड ऑफ ऑपरेशन? द ऑपरेशन इज यू कैन ऐड के, you can subtract k, and you can leave as it is, or I can say you can add 0 to the element. Okay, to make it simple. And ये ऑपरेशन क्यों करना है? To maximize the number of distinct element. Maximize the number of maximum distinct elements. Mhm. Okay, this is our aim. So let me just sum up the whole thing, otherwise इसका greedy solution तुम्हें समझ नहीं आएगा. Okay, हर एलिमेंट पे एक बार ऑपरेशन परफॉर्म कर सकते हैं. क्या क्या ऑपरेशन? आइदर प्लस की ऐड कर दो, या माइनस की ऐड कर दो, या प्लस जीरो ऐड कर दो. मतलब आइदर उस एलिमेंट को के से बढ़ा दो, आइदर उस एलिमेंट को के से कम कर दो, और वो एलिमेंट को एज इट इज छोड़ दो. Okay, so for people in south this is very simple, like either we can increase the value of the element by k, either we can decrease the value of the element by k, or we can leave it as it is. Okay, either of the three operation and you need to perform it. Now let us see the sample test case, how it is told. The sample test case has the element as, it has two ones, two. Okay, let us write in the same order as they were. So here we are told that the value of k is equals to 2. Okay, and what are the elements? The elements are 2, 4, 3, 2, 2, and then 1 itself. Okay, so now what we can do is, here for this 2 we can add 2, that would make it 4, but we already have 4, so that won't be any use. So we would subtract 4 because हमें तो distant चाहिए ना, so we would subtract 4. Okay, then we have something like we would add 2 to this 4. Okay, that would make it 6, and I can make this as 4. So now we have all the distant elements. What are the final elements? This is 2. So 2, 6, 3, 4, 0, 1. So every element is distant. So we can have at max 6 distant elements. So the answer to this is 6 itself. Okay. Now let us understand the very next example of this. The very next example would be that we are given 1 and 2 itself. We are given 1 and 2. So 1 and 2 are already distant, so we don't perform any operation. We leave it as it is. That is, we just add 0 to it. That would make the element same. So we have 2 distant elements. So that is why the output to this is 2 itself. Fair enough. So now just confirm that am I clear with the sample test case or not? Give me a quick 0 or 1. Am I clear with the sample test case or not? So, I did it with unordered map. I did it with map. An unordered map would also solve the purpose. It's normal for being not able to see the solution using the given solution link. No, you can go and see the solution for the first problem. Okay, you're done. Others, can I have a quick yes or no? थोड़ा वीडियो को लाइक वाइक करो, देखने के पहले लाइक हो जाना चाहिए. देखता हूँ कितने लाइक्स है. Okay. Thanks a lot, Neetu. Thanks a lot, Kusharga. Thanks a lot, Mohammed. Thanks a lot, Code with Akash. Thanks a lot, Siddharth Singh. Okay, fair enough. Same now. Okay, chill. Let's move forward. I would remove all these annotations because I would just analyze the test cases. Okay. So now, if you analyze the very first test case, okay, just let us have till this point. Let us say we know that these are the 3 options. This is our goal, and we need to maximize the number of distant elements. Okay, so what can we do? Let us analyze the very first smallest test case, first test case that is given. The first test case was that we are given 2, then we are given 4. Okay, let's first write it down. Okay, so we are given 2 3 times. 2, 2, 2. We are given 2 3 times. Then we are given 4, and then we are given 1. These are all the, and we are also given 3. These are all the 6 elements. 3 plus 3, that is 6. Okay. So now I can see that 2 यहाँ है. Okay. So what I can do is, if I add 2, like the value of k was 2. So if I add 2 to this 2, that would make it 4. But it is clashing with this 4. So I need to increase the value of this 4. Like I can increase and make it to 6. Okay. So yes, the value of k is equals to 2. Okay. Fair enough. So let's say I have 1, 2, 3, 4. And the value of k is, let's say at this point is 5. Okay. So let's say the value of k is, let's say 2. Okay. Let's take this example now. Okay. And we would try to make conclusion. Okay. We would try to make conclusion, or let's say observations. Okay. So now what I can do is, if I add 2 to this element, then it is clash. If I add 2 to this element, it would be 3. Sorry. It would be 3. But this 3 would collide with this 3. Okay. Okay. But if I add 3, let's say if I add 2 to the last element, that is the biggest element, that would make it 6. And it won't collide with any element. Why? Because it was already greater and we are making it more greater. Okay, like this 4 was already great. Now we are making it more. Like let's say even if we have 4, 4, 4, and the value is k, the value of k is, let's say, even as small as just 1. So even if we increase 4 by 1, it would be 5. And this 5 value would never collide. Okay, this 5 value would never collide. So this is very useful. Okay, yeah, more greater. So we are kind of safe side में जा रहे हैं. And see, we don't need to minimize the number of operation. हमारे पास है कि we can use one operation on each element. There is no price point if we don't use it. अगर मुझे पता है कि एक दिन में 10 रुपए मुझे मिलेंगे और एक दिन के बाद वो 10 रुपए खत्म हो जाएंगे. ओके, सो मैं उस 10 रुपए को खर्च करूं या ना करूं, that won't make a difference if we know that I am allowed to make 10 rupees expense in one day, and if I don't spend it, then after one day it would be gone. Then it won't make a difference if I use that 10 rupees or if I don't use that 10 rupees. Okay, so in the same manner we know that एक एलिमेंट पे एक ऑपरेशन करना है. अब उस एलिमेंट पे एक ऑपरेशन करो या ना करो, कोई डिफरेंस तो होगा नहीं, हमें कोई मेडल तो देगा नहीं. सो इट इज ऑलवेज बेनिफिशियल कि हम बड़े एलिमेंट को और बड़ा कर दे ताकि छोटे वाले एलिमेंट को बड़ा करने के बाद भी वो क्लैश ना करे. ओके, so like let's say I made this 4 as 5. Okay, and this is very safe. Why very safe? I would just show you. Let's say we have 3, 3 and 4. Okay, the number of distant elements are how much? The number of distant elements are 2 itself, 3 and 4. Now let's say we have the value of k as 1. So if we add 1 to this element, okay, and we add element to this, that is, it would become 4, then it is always optimal. Now we are leaving 3 as it is, then we are adding having it as 4, and then we are having 5. See, ये हमेशा मुझे optimal approach देगा. So our priority should be adding k. After adding k, our priority should be adding 0, and then after that our priority should be minus k. Why? Because adding k सबसे अच्छा था. वो बड़ा होगा तो वो कोलाइड तो नहीं करेगा. ओके, फर्स्ट रीजन. द नेक्स्ट रीजन इज, अगर बड़ा करने पे कोलाइड कर रहा है तो लीव इट एज इट इज. If after that, even after not making a difference, it is making a collision, then we can subtract it. Okay, let's debug this. Like, let's take this solution also, like how it is optimal for every case. Please give me test cases like this and I would be more than happy to tell it. Okay, so let's say we have 3, 3, 3, and then we have 4, and here we have k is equals to 1. Okay, so we would start from the largest element because बड़े को बड़े करने पे कोई दिक्कत नहीं है. So we would start from the largest element. We would add 1 to 4. That would make it 5. Okay, and that is not, 5 is not colliding, so we are happy doing it. Okay, we are happy doing it. The very next thing is that 3 plus 1 is 4. 4 is not colliding, so we would make this as 4. Okay, again we go to 3. 3 plus 1 is equals to 4. We already have 4. Then what I said, if adding, so the first, this is not possible. Okay, so addition of k is not possible. Then leave it as it is. So I left it as it is. Okay, I used this operation. Then after this, I am having 3. First I would add 1 to it. So 3 plus 1, 4, we already have it. Leave 3 as it is, we already have 3. Then we would go to 3 minus 1. 3 minus 1, that is 2. So now we would have all the elements, that is 2, 3, 4, 5. So this would always give a optimal approach. And I am happy that I found it, kind of. After a long time, I kind of did a tricky, greedy question. So this would always work. But it gave me a wrong answer. Okay, so no. Don't sort in ascending order. Sort in descending order. Why sorting in descending order? Because I told you. Let's see this thing very carefully. Okay, why sorting in descending order? Let's say this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, this is 8. Okay, so if you sort it in ascending order, if you add k to it, let's say the value of k is equals to 2, then it would definitely clash. It would make it 3. 3 is already present, so it would definitely clash. But if you add k, like whatever be the value of k, irrespective to the value of k, if you add the value of k to the last element, that is biggest element, like 8 plus 2 is equals to 10, it would never collide. So we would start from the biggest element, and our priority would be based on this. First we would check if after adding k it is present or not. If without adding it is present or not, else we would just subtract it, because हमें बड़े से छोटे पे आना है. So हम लोग कोशिश करेंगे. The intuition for that is, see, what is the intuition? Like how I got the intuition. The intuition is that bigger element, like see, 1, 2, 3, 4, 5, 6. I'm just trying to make every element go on that side, on the bigger side. Why? Because if I throw the element on bigger side, then it would collide less. But if I subtract it, then it would collide on this side. Okay, so I'm trying to make it throw on that side so that it doesn't collide. This is the intuition. Okay, now the idea is very simple. For each, we would just sort it on the descending order. And we would maintain a hash map that this value is already present or not, and we would simply use some if statement, and it is done. And the editorial solution is very complex. Okay, so why not on the smaller side? Because we started processing from the larger element. So larger ko large kar do. Yeah, see, you can just do the opposite also. Kuch bhi kar lo. It would solve the purpose. I did smaller, you can just do the opposite of it. Yep, by using map. एक मैप रखेंगे जो याद रखेगा कि ये वैल्यू हमने पहले देखा है कि नहीं. Whenever we want to remember if I have seen it somewhere or not, then we use map. Distant elements. Okay, fair enough. First, I would sort it in the descending order. So sort a dot r begin, or else you can just sort it in the simpler way and you can just reverse it. Okay, a dot r begin just sorts it in the reverse order. A dot r end. Okay, this is what sorting in the reverse order. Sort in descending order. Simple. Okay, then we can take unordered map, but to be on the safer side, I would just take map, because the worst time complexity of map is log n, but unordered map has a worst time complexity of big O of n. So I am kind of avoiding it. Then we would count the number of elements. Okay, and then we would start the iteration. For auto e of a. This is just a for each loop. This is what? For each loop. Just trying to make it as simple as possible. So first I would prioritize on what? I would first prioritize, the priority list would be plus k. Then the next priority list would be plus 0, and then it would be minus k. This would be the priority list. So first we would check if m dot find e plus k is equal to m dot end. Like plus k is present or not. If plus k is not present, then it is always optimal. So we would count one element that we were able to do it. And m of e plus k and then we would simply do plus plus, and then we would do else if, and we would kind of copy this thing. Okay, this would be, first was plus k, then it would be just e, that is plus 0. Okay, then it would be minus k, and this is done. Okay, okay, now just tell me the line number or the point at which you are not able to understand. But if you like if you just see, that I would just send you the code link also. Just give me a sec. Just mention the line number at which you are not able to. Okay, now just a small thing, that earlier this code was not working. Okay, you can't really blame it. Earlier the same code was giving a TLE. Okay, like the same code, first when I submitted it, this code was giving a TLE, then I debugged it, did a stress test or something. Then after that I got to the team, and on 6:52, 8 minutes before the contest started, this thing was done right. So you can't really blame the contest if you are not able to solve it. Okay, this time I took care. But if you just see the editorial solution, it is kind of very complex, and it kind of brings you to a different direction or something. Okay, so they took my solution. Okay, when I told the team, they just took my solution. So the hint is still still different. Like earlier, the internal solution was different, and now the internal solution is different. They changed the solution with my solution when I told the team. They are very cunning. Okay, please explain from line number 17. Okay, so line number 17, I told you that first we would try to see if plus k is present or not. Okay, so plus k was not present. Why? Because this just means that when it is m dot end, when we are finding something in a map and it is pointing to m dot end, it means that the element is not present. Translating the same in Hindi would be, जब भी हम लोग मैप का फाइंड फंक्शन यूज करते हैं और वो हमें m डॉट एंड रिटर्न करता है, इसका मतलब वो एलिमेंट प्रेजेंट नहीं है. ओके, सो इफ e प्लस k is not present up till now, then I would do e plus k, and I would increment that yes, one distant value is given. Now if e plus k is present, then next our priority list was to add 0. So now we would check if this is present or not. If it is pointing to m dot n, this means that element is not present, so it would increase the value. Okay, so now the third priority list is subtracting the value of k. Okay, then I subtracted the value of k. If it is pointing to the end, that means that the element is not present, and then I did it. Else the element is present and we can't really have convert it to a distant value. Okay, so else condition is not present. यही हो रहा है बस. By the way, I'm extremely sorry. When I saw the recording in the last interview series, someone asked me to explain. I started explaining, then I saw the time that it would be very late, and I skipped explaining. And and that was wrong from my side. So I'm extremely sorry. Sometimes I also make mistakes. So I'm sorry for that. Nice greedy approach, भैया. DP से कैसे होगा एक बार explain please. So basically what you can do is the DP would be 4 directional. Either you can add that element, either you can leave it as it is, or either you can subtract the element. So it would be kind of recursive. Okay, so recursive would be in 3 forms. Either it would add k, either it would leave it as it is, either it would subtract k. But DP is would be a overkill for this solution, because like I can say that dip is not at all required if you have a very simple greedy solution. Okay, thank you so much, Code with Akash. Srijan Kundu Chaudhary, am I clear to you? Like, let me just show you how the greedy approach would be, because don't want to fall in guilt or something. Next level greedy. To be honest, I also, like, when I found the solution, I was furiated, like, why this is not working. I like initially the solution, like, yep. So now let's see how the DP solution would work. So the DP solution, let's say we have here just two elements. Okay, let's say we have two, two, and two. Okay, so the greedy solution would be that from two there can be three kind of values. Like, we can start off with the first index, three kind of values. So from index 0, okay, we can have, if we just add k, let's say the value of k is equals to 2. So if we add 2 plus 2, that would make it 4. If we leave 2 as it is, it would be just 2. If we subtract 2 from as it is, it would be 2 minus 2, that is 0. Okay, now for the next element, it would also have three branches. Okay, let's just have two elements only, because it would be very overkill. Like 4 plus 2 is 6. 4, leave it as it is, it would be 4 only. 4 minus 2 would be 2. 2 plus 2, 4. 2, leave it as it is. 2 plus 2 would be 4. 0 plus 2 would be 2. 0, leave it as it is, it would be 0. Then 0 minus 2 would be minus 2. So this is how the recursion tree would look like. You can just implement the recursion, memorize it. You can have a tabulation form also by using the loop and all. And this is your TP solution. Okay, so now let's move to the last problem. Last problem also, I kind of had a workaround for this problem. Okay, so today I have a lot, like today I am very satisfied with this. Okay, so give me a quick one if this problem is clear. Give me a quick one. But yeah, I tried sorting it in the ascending order and then checked in the priority. Minus k plus 0 and minus k. For all the cases raises the question, then I took so smaller. Can you tell me why it is not working? I'm not really sure. It should work, but I'm not really sure. Okay, I can just try and then tell you. You can just remind me in LinkedIn that, yeah, did you try it or something? Okay, I didn't try it, so I can't say that it would definitely work, but it should work. Bhaiya, have you had not stored in map? Then bro. Okay. Srijan Kundu Chaudhary, am I clear? Am I clear? Am I clear to you? The greedy approach. Am I clear to you? Just confirm this. Now, let's see the last problem. Okay, I don't know why it is told the last problem, but when I saw the problem, I didn't think much, and I was able to find a, I was able to find an easy solution to this. Okay, now it is told that we are again given a tree. Okay, we are again given a tree, and all the n nodes and n minus 1 edges and all is given. Okay, but n minus 1 edge is not mentioned, but we are told that we are given a tree itself. So we would assume that this is a tree itself. Now we are told that we are given a value x and y. Okay, I don't know, it seemed to me as a easy problem, but still we are given two values, x and y. Okay, and that would be present in the tree. Okay, what we need to do is, we need to first check if x and y, they both belong from the same subtree or not. they both belong from the same subtree or not. This is the very first thing. If they both belong from the same subtree, then we need to find the GCD of the subtree of x if they don't belong from this, and then the GCD of the subtree of y, and then we need to find the GCD of both of them, and this would be our answer. Simple. Okay. So first let us understand what do you mean by a subtree. Okay, let us first understand what you mean by a subtree. Yep. So we would come back to this later on. So let us first understand what do you mean by a subtree. So let's say we have a tree kind of thing. Okay. Let's say this is the great grandfather of me. This is me. Okay, this is me, and these are my children. Okay, these are my children. Chota Siddharth Hazra. Okay, these are all my children. So this is how a family tree is. So subtree is nothing but the family from that node is known as subtree. Let's say I want to find the subtree of this node. Then this whole thing is the subtree of that node. Okay, family evolving from that particular node is the subtree of that node. Okay, this is not the bookish example, this is the easiest example what I assume and what I use. Let's say for this subtree, let's say for my great grandfather, this whole tree would be a subtree for my whole grandfather because the whole family has evolved from that point. And let's say for the leaf node, let's say like me, I have no children of my own, I have no family of my own, so the subtree of me would be just me, that the family evolving from me is just me as of now. Okay, fair enough. Now let us have the given tree. Now let us see how the test cases are built. Okay, first we are told that the tree is a rooted tree with 1. Okay, then we are told the first edge, that is 0 to 1. So we have an edge from 0 to 1. Okay, then we are told that we have an edge from 0 to 2. 0 to 2. Then we have an edge from 1 to 4. So we are having an edge from 1 to 4. Then we are having an edge from 2 to 3. Now this is the tree, but we have some value associated with everyone. This is given in the val array. Okay, so the value of 0 is 30. The value of 1 is 24 and it is given. And the value of 2 is 10. And the value of 3 is 20. And the value of 4 is 16. Fair enough? So now we are told that first we are given the value of x and y as what? The value of x is equals to 1. The value of y is equals to 2. First we need to find the GCD of x. First we need to see that x and y belong from the same subtree or not. No. The subtree of 1 is this one and the subtree of 2 is this one. Okay. Now, so now we need to find the GCD of subtree 2. So GCD of y would be GCD of 10 and 20. And GCD of 10 and 20 is just 10. Fair enough. Now GCD of 1. So GCD of 1 would be GCD of 24 and 16, which is equals to 8. Now, as I told earlier, whatever the value is coming up, we just need to report the GCD of both of them. So we found out the value of this and this. So the GCD, greatest common divisor, of 8 and 10 is equals to 2. That is why the ultimate answer is 2 itself. Okay, now let's see the next example also. Okay, I have some comments. Let me just see. What is the meaning of what is meaning of GCD? Greatest common divisor. Okay. Now we are told that 0 is the parent array, 0 is the root. Then the next example is we have an edge from 0 to 1, we have an edge from 0 to 2. Okay. We have an edge from 0 to 2. Then we have an edge from 1 to 4. And then we have an edge from 2 to 3 itself. The value associated are what? The value associated with 0 is 30. The value associated with 1 is 24. The value associated with 2 is 10. The value associated with 3, the value associated with 3 is 20, and the value associated with 4 is 16. Okay. So now in this scenario, if you see the value of x and y, x is equals to 4 and y is equals to 1. But if you observe that 1 and 4 both belong from the same subtree. So that is why the answer to this would be -1. Okay. So the idea is very simple. First, what do we need to do? We need to check if both belong from same subtree or not. This is the very first thing you need to do. Okay. So how to check if they both belong from the same subtree? Okay. The idea is very simple. What we can do is subtree is what? Okay. So this just means that both belong from the same family or not. Both belong from same family or not. Okay, both belong from same family or not. This is what is asked. This is what is asked. No? So now to check if both belong from the same family or not, like let's say I have a very big family and I live in a joint family. And I want to know if someone named as Aman lives in my family or not. So what will I do? I would search in my whole family if Aman is present or not. Okay. This is the very first approach, but there is a problem associated with it. Okay. That given a tree, okay, 1, 2, 3, 4, like let's make a big tree. Let's make a big tree that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Now let's say if I ask 4, that is 6 in your family or not? You can start from 4 and you would say yes, 6 is present in my family. Okay. But if you ask 6, is 4 in your family or not? If you go down and search, you won't find 4. Okay. So you would say it is not in my family. So what we need to do is we need to do a search from both of them. We are given x and y. So we need to search the family of x as well as y. We just need to go downwards for both x and y. If in either of them we find the other node, we would say yes, this is present. What I want to convey is, translating the same in Hindi would be, हम क्या करेंगे, x से नीचे जाएंगे, देखेंगे y मुझे मिलता है कि नहीं. अगर y मिल गया तो सही है, भाई दोनों एक फैमिली से है. अदरवाइज y से नीचे जाएंगे और देखेंगे x मुझे मिलता है कि नहीं, बिकॉज वी आर नॉट श्योर विच वन इज अबव, x इज अबव और y इज अबव. बिकॉज इफ वी ट्राई टू सर्च, लाइक अगर हम लोग 4 से 2 को सर्च करेंगे तब मुझे 2 नहीं मिलेगा, बिकॉज वी आर सर्चिंग डाउनवर्ड्स. बट इफ आई ट्राई टू सर्च 2, but if I try to search 4 from 2, then we would be able to find 4. That is why we need to do a searching from x as well as y. I hope I make sense. So this is how I can check if they both belong from the same subtree or not. Okay, by simply doing a DFS downwards. Okay, by simply doing a DFS downwards and trying to search the element. Simple enough. So am I clear with the very first thing? Give me a quick yes or no. Suppose we have 2, 3, 4. Then the GCD of 3, 4 we have to take. Yes. Am I clear with this? Give me a quick yes or no. Let me just see the number of likes. Okay, let's move forward. So now we just need to find the GCD of the tree, subtree. So that is also very easy. Just start from. So GCD of the subtree, either of the subtree would be very easy. Just start from either x or y and move downwards. Okay, like let's say we are given a subtree as well. Let's say we have some values like 10, 20, and then let's say 5. So what we can do is we can initialize the GCD with 10. Then we do GCD of 10 comma 20, which is equals to 10. Then again GCD of 10 comma 5 would be 5. So this is how we can find the GCD. And you can use this GCD function of C++STL itself. Sending you this. So we can directly find the GCD inbuilt by doing this. Okay. We don't need to code GCD by Euclidean algorithm. Okay, like to find GCD we need to use Euclidean algorithm, but we already have it in the C++STL itself, so it would be very easy. Now let's move to the coding part and it would be good to go. Okay. Floaty the board builder. I can have this. Okay, first we would code the find function, that from x we need to find y. So I would say find. Here I would have the source and here I would have the destination. That from source I want to find b. Okay, and then I would have the vector int g dash, that is the graph itself, and then I have the value. Okay, so if I find it, then I would make the value as 1, that the value would be made true. Initially we are taking up a boolean value, we are making it with false, and if we are able to find y from x, or if we are able to find y from x, then we would say that this value is false. अगर हम लोग एक बुलियन लेंगे उसका वैल्यू इनिशियली फॉल्स कर देंगे, अगर x से y मिल गया या फिर y से x मिल गया तो उस बुलियन का वैल्यू हम लोग ट्रू कर देंगे. Okay, so we would say if the current node is equals to d, that is agar mujhe mil gaya, then I would simply say yes, that we have found it, and we would make value as 0. Else we would just iterate on the graph itself, g of s, and we would say find the value of e, and like the source, this destination would be same, and the graph we have it, and then the value would be made same. Okay, fair enough. Now we have the DFS. Now we would just like find function is done. Now let's build out the graph. Very lazy person, so we would be using what? Instead of edge, what do we use? Just e. Instead of the val thing, what is this val? Val क्या है भाई? Okay, value is the array itself. Okay, we should we touch it? कर देते हैं, we कर देते हैं. Okay, fair enough. Now we would make the graph. So we would have vector vector int g of size n, and then we would have the graph. So now what I would do is for auto e dash g. So we are given the elements in the form of pairs 0 and 1. So int u would be e dash 0. The first element would be u, and the next element would be v. Okay, 0 and 1. Fair enough. And this would be e of 0 and e of 1. Yep. Okay, now g of u dot push back v. I'm making it a directed graph so that I don't need to use visited array. You can make it an indirected graph, but the usage of visited array is required. Okay, so now as I said you, I would make a boolean variable. I would initialize it with false. Then I would try to find y from x. So find from x, I need to find y. Okay, and then I would do find from y, I would try to find x, and then the general things that are needed, that is the graph is needed and the value array is needed. Okay, the value array is the okay itself. Yep. Then g and then okay itself. Done. Okay. Now if after this point, if okay becomes true, that they both belong from the same subtree, then I would return -1. दुख के साथ खेद है, यहीं पे बंद हो जाएगा, यहीं पे कहानी समाप्त हो जाएगी, so called. Okay, that now GCD of x. Now we need to find the GCD of the subtree. Now let's just code a function which would calculate the GCD. We can simply do a we can simply traverse downwards in DFS, and we can just take up all the elements. So we would say int DFS, and then we would have the source. From there we would start, and then we would initialize it with a GCD. Okay, this is the first GCD, and then we would have the vector int array, and then vector int array यहीं पे copy हो जा भाई. Okay, and then we have the array of tiers. Now I would say GCD is equals to dash dash GCD. Told you. Then I would say GCD of what? GCD of GCD, comma the current element value. That is V of S. Because the value is stored in where? Value array. That is V array. Value को हमने V कर दिया. Shortcut है भाई. Okay. And then we would traverse G of S. And then I would say DFS of this current E, and the GCD would be retained by the time, and then we have the graph array, and then we have the value of G itself, and then it's done. Okay, then we would say G of X. Okay, GCD of X is equals to GCD of X equals to, first we would initialize it with a very the value itself, and G of Y is equals to V of Y. Fair enough. Then we would simply run a DFS. Okay, that is x and then gx. Okay, and then g and then v itself. After this, we would do the same thing for y and gy, and then g and the vector array v itself. And then we would return the GCD of gx and gy. GCD of gx comma gy. Segmentation fault. शुरू हो जाओ. Well expected. चलो देखते हैं. So am I visible still? Yep, I'm visible. तो चलो debug करते हैं. We are given S and D and then G and then val. Good enough. If S is equal to 2, we would make the val and then we would find the val of this. Good enough. And then we would find the GCD of V of S. Yep. And then for int E, then GCD of G and V. Good enough. So now I think this is making an error. For int I is equals to 0, I is less than E dot size itself, and then I plus plus, and this would be E of I dash 0 and E of I dash 1. And G dot pushback from U to V. Then we would make OK is equals to false. If by chance OK becomes 1, then X and Y, G and Y. कहीं पर कॉपी वेस्टिंग में कोई गलती. X G and V, X G and V. Now it should work. Chalo, let me give you the solution. Tell me the line number at which you are not able to understand. ओहो, ये लाइन कितना बार बोलना पड़ता है. Okay, fair enough. This is the link of the solution. So this is the solution that was mine. If you just go to this, they are finding out the LCA and all. Lowest common ancestor. The knowledge of lowest common ancestor is not needed. Okay, we don't need to find lowest common ancestor. We have two nodes only. If there were multiple nodes, then LCA was required. But if we have two nodes, then either ये होगा या either वो ऊपर वो होगा. So search from both of them, and it would be done. Yep, LCA and all is not required, to be honest. Okay, now tell me. Okay, just give me a quick one. The number of live viewers are more. So we would just check the number of likes.
Search and compare rates on trip.com.
Now let me see the number of likes. The number of likes is just 32. Then can you please increase the number of likes, everyone? Can everyone please like the video? Please quickly like the video. হয়ে গেছে এন্ড করো. Okay, so now I would be waiting for the next 1 or 2 minutes. If I don't receive any doubts, I would be turning off the stream. So if you want, as the stream ended a little bit early today, if you want, you can just ask me. By the way, one simple thing is that when I was like, just told it, when I was in my initial days, what happened was, like when I saw the editorial or let's say solutions from others, I found out that it had a easy solution, and then I kind of felt demotivated that I'm not even able to think a simple solution like this. Okay, but I would say that thinking a simple solution requires experience as well as a lot of practice. So more experienced and more practiced you are, more simpler solution you would write. So don't just see the solution and judge yourself that you are a very inexperienced competitive programmer. Everyone, everyone goes through this phase, and everyone feels that इतना easy solution होने के बाद भी मैं solve नहीं कर पाया. It's not that. It's just that मैं solution को easy नहीं बना पाया. Think it this fashion. Bengali, हाँ, কেন কি আমি Bengali? Okay. So that's it for today. I'm not receiving any doubts. So that's it for today. Thank you and good night, everyone. All the best for your next contest. Bye bye. And if you're watching this stream in the recorded version, feel free to like and comment the video so that my hard work could be justified and I can have a smile on my face. That's it. Thank you.